There are two types of electrical maintenance techniques: condition-based and time-based. For time-based maintenance, or TBM, equipment is checked and maintained only on a calendar basis. For condition-based maintenance, or CBM, the environment and operational conditions dictate the schedule for maintenance. Properly performed CBM programs are the best way to make sure your electrical system will work safely and reliably when you need it. One very powerful condition-based maintenance tool is infrared or IR scans. I remember when we started the services group at Eaton in 1998, I was responsible for buying IR cameras, and at the time, I remember specifically that they were $65,000 each. It was hard for me to believe back then that it was worth buying those cameras, but they were needed and a very valuable addition to the capabilities of our team. Beyond the cost of the cameras, the people trained to do the testing, called thermographers, required very specialized training, adding to the cost and limitation of who could use them. Since that time, a lot has changed to make those cameras more affordable, and the methods of doing the tests have become much safer. In this video, you will see how significantly IR scanning has progressed over the years and how it plays an important role in condition-based maintenance programs. So why would you do infrared or IR scans? Because you can't see electricity and the heat that it creates, we rely on well-proven designs and installation practices to avoid problems within our electrical systems. Still, many times you won't know there's a problem until there's a failure. Yet the problem was fully discoverable well ahead of the failure. A majority of potential causes of electrical failures are stealthy. You often don't see or hear them coming. Loose connections, overloaded transformers or conductors, current imbalance issues, corrosion, moisture ingress, aged or weakened insulation, and faulty prior maintenance procedures are all documented causes of electrical fault conditions which can generate heat. And some failure causes, like partial discharge, will not result in a temperature rise as a warning before failing the equipment. These failure modes are in fact discoverable prior to a fault, and I'll discuss this a little bit later. IR scanning is done to identify temperatures above a baseline as indication of an impending failure. Looking at three different types of lights, including LED, fluorescent, and incandescent, highlights the significant difference in operating temperature using an IR camera. Likewise, thermal issues in switchgear, conductors, breakers, and other electrical connections become equally apparent to a trained thermographer. The next question is, how do you perform an IR scan? In the early days of IR scans, when the cameras were very expensive and you had to attend special classes to know how to use them, the opportunity and cost to do the scans was very limiting, although the benefits proved to be well worth the effort. The early cameras used liquid nitrogen to obtain good thermal images of electrical systems, and because of that, the duration of the testing and the output was typically limited from a time standpoint. So you would normally go around your facility and remove all the panels and covers of the equipment that you intended to scan in preparation to do an efficient evaluation. Because of all the recent changes in the standards around electrical safety and arc flash, these procedures are disallowed in most instances, or at a minimum, require much more of an effort to maintain a safe environment while you walk around in your 40-calorie suit. Today, the cost and form factor of the cameras has changed by an order of magnitude or more. You can now connect a small IR device to your phone and obtain very good resolution images of your equipment. In some cases, the equipment is so inexpensive that it makes more sense to have it permanently installed inside your equipment for critical loads like UPS or some switchgear. The portable cameras are much more portable, and with a good battery can last much longer than you would need for a typical maintenance scan. Sure, you can still buy a very expensive camera that has lots of bells and whistles, but I'm pretty sure you'd have a hard time finding one that's $65,000 like the ones I bought all those years ago. The next questions that need to be answered are, if you're going to implement IR scanning, what is the most efficient and effective way to capture condition-based data that you might need, and how do you access the equipment to be scanned safely, efficiently, and economically? The typical equipment that you would need to access to perform IR scans includes panel boards, switchboards, switchgear, MCCs, busway, transformers, and other electrical equipment. The compartment covers of the equipment maintain an environmental barrier to the energized space and maintain that space in a fully closed and guarded condition while the gear is energized and operating. These two reasons are why you don't need any special PPE when you simply walk past the gear or stop for a moment or two to examine something visually from outside the gear. To perform IR scans on most of this equipment, covers need to be removed, which could result in arc flash or shock hazards. So what's the solution? For spot checking or troubleshooting specific equipment that may have issues, electrical workers dress in appropriate arc flash suits and carefully remove covers where possible. Eaton has developed many solutions to minimize the risk of removing covers so that they don't fall back into the transformers, switchgear, or panel board. Solutions like hinged doors and easy trim covers make for a much safer opening or removal of doors. However, for many years now, opening energized electrical equipment for any reason, including for energized inspections, aside from potentially being a safety hazard, is either prohibited outright by the site owner or prohibited or severely restricted by OSHA, NFPA, or others. These prohibitions exist regardless of workers wearing a 40-calorie suit. In addition, even if it's allowed, it usually requires prohibitively expensive manpower and operational downtime cost to the site owner or operator to do so. Luckily, there's a fairly straightforward solution: IR windows and panels. Early versions of these windows were single, small, round windows that had to be strategically placed to see anything. In addition, they were opaque or had that frosted look that would allow an IR camera to see through, but you couldn't visibly see through it. The problem with this is that many times, if you found an issue with the thermal camera, you still needed to remove the cover to see what the camera was actually seeing. Today, there are much better options available. Installing properly designed, tested, certified, sized, and placed infrared inspection windows or panels will mitigate these issues, risks, prohibitive costs, and a lot more. If you've made the decision to implement an IR window or panel in your CBM inspection program, it makes sense to install an IR window design that allows you to capture the most useful energized inspection data. With all the new options available, there are several things to look for in a properly designed IR window. Here are some of the key features to consider. First, a properly designed IR window should be made of a robust polymeric material, as these polymers are impervious to all the physical and ambient conditions, which will follow a crystal lens. Crystal lenses typically are hygroscopic, meaning they absorb moisture from the air naturally. Polymer lenses absorb nothing and they offer a fixed and stable IR transmission rate. In other words, without a polymer lens, issues may result from moisture in any form, ambient temperature swings, vibration, exposure to an array of mild acids and alkali solutions, etc. Next, you should always use a visually clear IR window or panel to allow for visual inspection of the energized compartment, as well as infrared capable with any IR camera, shortwave, medium wave, long wave. This allows you to take digital photos while you're doing IR scanning. This will really help you to match the physical location with the IR images for reporting and analysis purposes. In addition, the construction of the IR window or panel should be in compliance with UL, CSA, and other applicable standards. It should also be approved and tested for arc containment. In other words, by putting this window or panel in your equipment, the arc flash containment of the original equipment should not be diminished if this cover is closed and properly latched. Finally, while you're making the investment in this solution, we highly recommend that the construction of the window should have integrated sensor options available to measure airborne ultrasound and partial discharge, and should be compatible with the major brands of handheld testers available today. These testers can detect electrical faults and conditions acoustically when they first emerge and before temperature rises occur. And partial discharge faults are likely to never issue a temperature rise ahead of the equipment failing. A properly designed IR window or panel should, from its single installed point of access on the gear's compartment cover, enable all of these critical energized inspections to be performed while maintaining the energized compartment in a closed and guarded condition while the gear is operating and under load. All of this, as an example, is what you see mounted here on display at the PSEC. So today, with the right camera and taking advantage of the latest technology and innovations, IR windows strategically placed on the equipment can allow you to do scans without having to deal with the arc flash or shock hazards. You can obtain the data you need safely and efficiently, and you can actually do the testing more frequently, thereby giving you a better chance of preemptively finding thermal problems on your equipment. Once you've established that you need windows, where and how should you install IR windows? For new equipment, consider installing IR windows capable of showing the wiring terminations or connection points on breakers, busway, and transformers. This can include windows mounted on switchgear, switchboards, MCCs, or other assemblies. This layout, for example, shows some great options for replacement gutters or covers with IR windows mounted on a switchboard. These windows are now available for standard and custom sizes of covers and gutters. For panel boards, consider replacing a cover with one of these IR windows that would allow you to scan all of the connections of the breakers, which is where most of the overheating or issues occur. For busway, here's an example of the termination points that might be worth monitoring over time. For existing equipment, almost all of these options can be retrofitted during routine maintenance with standard legacy equipment using standard size replacement covers or custom covers designed to match the equipment. If you are responsible for designing or maintaining electrical power systems, infrared scans are likely part of your maintenance procedures and design considerations. There are a lot of new cost-effective technologies to keep you safe while you perform IR scans. If you want to learn more about these designs, contact us or your local Eaton representative to schedule a visit to one of Eaton's Power Systems Experience Centers today.